Welcome to Spring LIB.
So let's say the tension for this book, the red book, is T1, and the tension for the green book is T2. So there should be a difference in tension for these two books because there's a net torque on the pulley. So we'll be applying F net equals to mass times acceleration for this linear motion because the book is going, for this case the book is going down linearly, and for this case the book is going on the right side linearly. So we'll be using F equals ma, and for the pulley we'll be using tau equals to I times alpha, because it's a rotational motion. Now, first of all, let's see what's given here. So we are given the mass of the two books. So we know that M1 is 2 kg, M2 is 3 kg. So if this one is heavier than this one, so of course this should go down. Now to evaluate, let's say that the positive x direction is in the direction of the acceleration of each book. So if the book is accelerating is in this direction, then we'll consider positive x for this part. And if we consider this part separately, so let me mark this part. So if we consider this part separately, then we'll consider downward direction as the positive x direction. So for this part, we'll have, so I'll just write that down using red ink. We'll have x minus x naught, which is equal to v naught in x direction times t plus half of ax times t. And from here, we know that the system started from rest, so we can ignore this part. So we'll have ax, which is equal to 2 times x minus x naught divided by t squared. And from here, we know that x minus x naught is 1.2 meters and t is 0.8 seconds. So our acceleration will be 3.75 meter per second squared. So if we say this is A1, which is related to mass 1, this is 3.75 meter per second squared. Then this acceleration will be gravity times this acceleration. So T1, or the tension on the red book, will be mass times the acceleration on that book, which is 7.5 newtons. And for T2, we'll have mass of the second book, which is 3 kg, times A2, which is, as we mentioned, that A2 is nothing but G minus A1. And combining all the numbers, we get the tension as 18.2 newtons. For part B, when we need to figure out the net torque on the pulley, or we need to figure out the moment of inertia of the pulley. To do so, first we'll see that there's a net torque because they are not equal. So the net torque will be the difference of the tensions times R, since we know that torque is force times R, and here force is nothing but the tensions on the cord. So we will have a net torque as T2 minus T1 times R, where R is the radius of the pulley. And using the numbers, we'll see that this quantity is 0.803 Newton meters. So also the angular acceleration will be a1 times r, which is 50 radians per second squared. So the moment of inertia will be torque by alpha, which is 0.8003 Newton meter by 50 radians per second squared, and that gives us the moment of inertia as 0.016 kg meter squared. Thank you.